The next skill in P9 is to be able to solve a linear inequality. Okay, and the answers that we get are actually going to utilize solution set notation that we just watched a video on. So the idea with solving a linear inequality is, think of it as solving it with an equal sign. How would you do that? Well, you'd get the x's alone on one side and you'd get everything else on the other side. Same idea here. So if you want to, for right now, it is possible for you to think of having equal sign in between here. But again, you really should keep this inequality sign in there. So if I go ahead and solve this first one, I'm going to subtract 3x from both sides, and then simultaneously I can add 2, because then all the x's will be on the right side, and I'm going to add 2. Okay, and when I do that, let's see, I'm going to get negative 2 less than or equal to 2x. Okay, and this form always bothers me, so I like to have my x's on the left side. So if I have 2x minus 2, what actually ends up happening is that your inequality stays the same, but as you move the 2 to the other side and the negative 2 to the right side, you will end up having the inequality in the other direction. And then if you solve here, divide by 2, you'll get x is greater than or equal to negative 1. Okay. One thing that I want to warn you about, so this is a warning, when you divide by a negative, the inequality switches. Okay, so if I were to divide by a negative 2 instead, it would be the other direction. Okay, and then last thing, so what this means is that x attains all values greater than negative 1. So on my number line I put negative 1, okay, and then I need a closed dot. So a greater than or equal to sign corresponds to a bracket or a closed dot, and then we have to go forever to the right. And using interval notation, we saw how to write this. This would be the interval from bracket negative 1 to infinity. And then remember in section P9, we were really specific about you using the language. Where'd my cursor go? The solution set for x is this, and that would be your final answer. Okay, let's do another problem here. Okay, so the next one says determine the solution set for the inequality below. We're going to go through the same process. We're going to get all the x's on one side and all the non-x's on the other. But to begin with, well, this looks to be a little bit more challenging, mainly because there's stuff here that has x and stuff that doesn't. We have fractions. Well, in any case, when we have fractions, you normally begin by finding a common denominator. So, well, this one, the denominator is 1, so I have to look for 1, 5, and 2, so that's 10. And so I need to multiply make sure that everything gets to a common denominator of 10. And so that is going to be 30 over 10. And let's see, this next one I need to multiply by 2, or multiply top and bottom by 2. So that's minus a 4x minus 2 over 10. And then less than or equal to x, 5x over 10. Okay. And then I can simplify this all, so this is going to be 28, nope, just kidding. Let's see. So the constant's on the other side, 30 minus a negative 2. So remember, this negative distributes to both. That's the error that I made. So this is going to be 32 minus 4x and less than or equal to 5x all over 10 on both sides. Okay. And now, since I have a common denominator of 10 on each side, I could multiply both sides by 10. And when I do that, the denominators would cancel, and I'd just be left with 32 minus 4x less than or equal to 5x. Okay. And I'm going to need a little bit more room here. Okay, then I go ahead and solve this linear inequality. So 32 less than or equal to 9x. And then x is, let's see. And let's actually redo that. So next step would be to divide by 9. 9 is positive, so I don't have to worry about switching the signs or the inequalities direction. So 32 ninths is less than or equal to x. And so again, I don't really like this form, so what I would do is I would write it as x and 32 over 9. Okay, this was opening towards the x, so now it's x is greater than or equal to 32 ninths. And if it helps you to put this on a number line, feel free to, but you don't have to. And so my answer would be the solution set for x is, and then this, again, since it's a greater than or equal to, it'll be a bracket 32 ninths to infinity. Okay. So that one was a little bit more complex just because we had to get a common denominator first. The last thing that you may see in problems in this section is something that looks like this, and this is called a compound inequality, where we have x, we have an expression for x, but then we have values on both sides. We have an inequality, we have it kind of trapped between two inequalities. So the idea with this is go about business as usual, so isolate x, and to do that, if we do one operation, we do it in all three places. So the first step in isolating x would be to subtract 9. So I'm going to subtract 9 from all three parts, so from the 13 and from the 29. And this maintains equality. So let's see, if I do that, that's 4 less than or equal to minus 4x less than 20. Okay, then the next step would be to divide by negative 4. Okay, so if I do that, I get 1x, and divide by negative 4, that's minus 5. Now remember, when you divide by a negative, that switches the direction of the inequality. So this less than or equal to becomes a greater than or equal to, and this becomes a greater than. Okay, then if I put this on a number line, just so we can see this graphically quick here, let's see, I have negative 5, and I have 1, and greater than or equal to, you have a closed dot. With a greater than, with no equality, that's when you have an open dot. And now this says all values that are less than 1. Well, before I complete this, I actually want to rewrite this. So again, I don't like the x, or I don't like using less than in these cases because it's hard for me to see. Oh, shoot. So if I rewrite it, it'll be x less than or equal to 1 and minus 5. So this says it's the numbers that are between negative 5 and 1, exclusive on 5 and inclusive on 1. So it's these numbers. And then with this, we can write our solution set. So the solution set for x is, And then this interval is all the values that we're looking at. So -5 with a parentheses, comma, 1 with a bracket. And that'll be our final answer. Okay, so in this video we talked about solving linear inequalities, basically the same as solving a linear equation, just with the inequalities. Big things to remember are to write the solution set is, but then also when you divide by a negative to switch the sign. Okay, and then your answer should be in interval notation.